Hey guys, I'm going to do a couple of problems from our the packet that I gave out the other day. And I want to start off by saying that I'm going to de-emphasize the exponent laws at the end. I'm not sure if they're going to be on at all. We'll talk about that on Monday. But I would emphasize studying the other things in there. So that would be the equations with rationals in it, so those messy fractions, the equations with radicals in them, and then sort of the domain, range, and the graphs of those functions with the square root in them. So we'll go through all three of those things right here. Okay, so the first one I'm going to start with is what was that good one that I wanted to look at? This guy right here, number 5, okay? So if you look at 5 on your thing, and again, I encourage you to pause me before you do these things, or before you watch and try to do them yourself. It's going to be the best way to learn. So go ahead and pause me, and then we'll go ahead and try this guy. Okay, so we're looking at this this equation here, and there are a couple of denominators. And the first thing I want to do is I want to factor this guy underlined in red, right? So off to the side, we're going to say, oh, I can factor x squared minus 2x. And that just, they have a common, they have an x in common, right? So that can turn into x times x minus 2. So I'm going to rewrite the original equation with that factored form, right? And we now want to find the common denominator between these three things, right? Really, this guy's imaginary over 1, right? We don't have to write that if we don't want to. And I want to find the common denominator. And now we see that they each share this x in common. They share an x in common, right? And then this guy has an extra x minus 2, because that's how we factored that. And you can think about off to the side, what if I had like, my original problem was, like a third equals a sixth plus x, and I wanted to find a common denominator. Well, you know that that's 6, because you know 3 goes into 6, but we can think of that like 1 over 3 equals 1 over 3 times 2 plus x. And if you think about it, that's exactly what we have over here. I have 3 times 2, and here I have x times x minus 2. So my common denominator on the right side would just be 6. My common denominator on the left side is going to be x times x minus 2. That sort of makes all the bottoms go away. So let's multiply both sides by x times x minus 2. Remember, that means every numerator gets an x times x minus 2. If you want to skip this step because you think you've got it, that's totally fine. Oops, forgot the x here. Right, every numerator gets an x and an x minus 2, including this 1. It's really a 1 times these things. Okay, well, now let's cancel stuff. So first, my x's get canceled. Then these x's get canceled. Then these x minus 2's get canceled. Right? Notice I can't cancel the x in this x, because that x is involved in a 3x minus 3. Okay, and then now I want to just FOIL some stuff out. So I have 3x minus 2, I have 3x minus 3, and then I have this guy on the left, which is just our common denominator. X times x squared, x times negative 2, 2x, right? So this is just a quadratic. And remember, do not say square root both sides. That will make me very sad. We're going to put 0 on a side. Okay, we're going to put 0 on a side. And then we're going to get x squared. I'm going to combine these guys, 3x and 2x. Right, that's just 1x. And then we have another x over here, so that's actually plus 0x. And then we're going to have a minus 2 and a minus 3, so that's going to be minus 1. X squared minus 1 is what I got there. And again, all we did was combine terms, right? We combined all the blue guys, and we combined all the green guys. There we go. And you can see how to turn it x squared minus 1. Now this thing factors, this is a difference of squares, right? So it's going to factor into x plus 1 and x minus 1, because they're going to eliminate that middle x term. So that means that I'm going to get x equals -1 and +1 as my two answers. And remember, with these kinds of problems, we did have to check, right? Do they work, or is any rational undefined, right? And that meant were any of the denominators equal to 0? And we see that they won't be the case, right? They won't be 0. If I check -1, I'll get 1 over -1 equals -3 minus 3 over 1 plus 2 plus 1. Now, those aren't 0. And if I check +1, I'm going to get 1 over 1 equals 0 over 1 minus 2 plus 1. So they both will work. Okay, that was 5. Let's move on to, I don't know, what's another good one to try? Maybe I'll do 10. Does 10 look fun? Sure, we'll move on to 10. So again, pause me, try to do 10 on your own, and then, well, 10's too similar to that last one. We'll do it. We'll do 10. Okay, so we got 1 over x, and then I've got x plus 4 over x, and then I've got 1 over x squared plus 5x. 1 over x squared plus 5x. Okay, and how would I approach this guy? Well, again, I would factor this right guy and say that is just 1 over x times x plus 5. Okay, the other thing you could do right away is you could combine these terms on the left. You could, if you saw that. I'm not going to, even though that probably would be the smartest thing to do right now. I'm just going to multiply by my x times x plus 5. And we'll see where that gets me, okay? Because maybe we didn't see that, and this sort of process will still holds, right? So I'll have x times x plus 5 over x plus x times x plus 5 times x plus 4 over x, and then I'll have x times x plus 5 over x times x plus 5. Let's cancel some stuff. So the x's go away, the x's go away, and everything goes away. Okay, so that leaves me with x plus 5. Over here, I'd have to FOIL this, so I get x squared, I get 4x, I get 5x, and I get 20. Then over here, I just get 1, right? Because there's still a 1 there. So moving everything left, I'm going to get x squared plus 10x plus 25 plus 24 equals 0. So I'm looking for two numbers that multiply to be 24 and add to be 10. Of course, that's just 4 and 6. So I'm going to get x is -4 or -6. Okay, you would check both of those over here, right? And again, right, I'll leave that to you guys. They both work, right? They both work. Neither of the denominators becomes 0 in those guys. So that's good. That's good. I do want to try one more challenge guy. It's not. Well, we'll address that in class. We'll address that in class. Never mind. Okay, so let's move on to my radical friends. My radical friends, and we're going to do the first one where I just have one square root, and then my later ones where I have multiple. Okay, so let's try, we'll go sort of out of order. We'll try 18 first. Let's try 18 first. Okay, so 18, I have n minus 1. The square root of 6n minus 14. Okay, there's only one radical here. I've isolated it, right? If there was like a +1 on the right side, I'd want to move it to the left, right? But it's a -1 over there. Okay, so I've isolated the radical, right? Isolate a radical, and then square both sides. And then maybe repeat. And then after here, right, check Check. Okay, so we square both sides. And when I square this left side, we're going to remember that that's really foiling, right? That's really foiling. We can square both sides. We might get an extra answer. So when we FOIL this thing, right, I'll leave this to you. You're going to get 2n or minus 2n plus 1. And then over here, we're just going to get 6n minus 14. Okay, so again, we FOILed the left. We're going to subtract 6n. We're going to get n squared minus 8n. We're going to add 14, and we're going to get plus 15 equals 0. Plus 15 equals 0. So I'm looking for numbers that add to be negative 8 and multiply to be 15. Right? Take some time and do that yourself. Of course, that's negative 3 and negative 5. So I'm going to get n is 3, or n is 5, when I set both of those equal to 0. And now we are checking over here. Okay, so we're going to check them. And here we actually have to do it out because we have to make sure that our answer works, right? So if I have 3 minus 1 equals root 6 times 3 minus 14. Let's see if that's true. That means that 2 equals root 18 minus 14, which is root 4. And that is true. That's good. Let's try my other guy. That would be 5 minus 1 equals root 6 times 5 minus 14. And that would be 4 equals root 30 minus 14, or 4 equals root 16. That's good, okay? I need to see that work that we've sort of gone through and checked both sides, okay? So let's do an a less pleasant one. We'll do maybe 17 together. 17 a good one? I hope so. Whoop. My laptop's kind of screwing up here. So let's do 17 together. Okay? So this guy has 2 radicals, and they're different. I'm going to use, if you guys will allow it, I'm going to use x instead of m. M is, not my favorite way to use, so I'm just going to switch to x. Okay, so I now need to isolate a radical. Done. We've isolated the radical on the right. Square both sides. Okay, so if I square my left side, remember that's this thing times itself. This thing times itself. On the right side, it's just going to be that thing times itself, which is just 4 minus 7x. Okay, so let's multiply this thing on the left times itself. Well, the first piece of foiling, right, I would get negative 3x. My next piece, I would get plus 2 root negative 3x. Here I get another 2 root negative 3x. Here I would get a 4. This equals 4 minus 7x. Okay, now again, when we said repeat up here, repeat right here, we need to potentially isolate a radical again. So I'm going to need to isolate root negative 3x because it's still living in my problem. Okay, so I'm going to do negative 3x. I'm going to combine like terms over here. So I have 4 of them. I have 2 plus 2 of them. Okay, and I have this thing. I'm going to add 3x to both sides. Okay, so that's going to be a negative 4x over here. And I'm going to subtract 4. So these 4s are going to cancel, right? These 4s right here go away. So I end up with something that looks like this. Now, when I say isolate a radical, we don't actually have to divide by 4. Okay, you could square both sides right now. I am going to divide by 4, right? I'm going to divide both sides by 4. And I'm going to be left with something that looks like this. Okay, and now I want to square both sides again. Okay, so we square both sides again, and on the left, I'm going to get this times this, and on the right, I'm going to get this. Okay, because we're squaring both sides. Okay, the left becomes negative 3x, and the right becomes just x squared, because the negative is going to cancel. The negative is going to cancel. Okay, and then that would mean I would have 0 equals x squared plus 3x on this side. okay? And now all of you might want to square root that thing, which would be very, very tragic, okay? I hope not all of you. Some of you might want to square root that thing, okay? We saw this on our mid-year. If we're going to see it again on this assessment, I can promise, okay? So when we are trying to solve this guy, we factor an x out, right? And this means either x is 0 or x plus 3 is 0, which would mean x would be negative 3, right? We are all going to solve things that look like this guy. I'll circle it in red correctly next week, right? So that we'll all be happy, okay? And now over here on the right side, we're going to do our check. So here for x equals 0, we're going to say negative 3 times 0 plus 2 equals root 4 minus 7 times 0. Well, this thing's just 0. And this thing is just root 4. So that looks very nice. What if x is negative 3, though? If x is negative 3, well, then I'm going to have negative 3 times negative 3 plus 2 is 4 minus 7 times negative 3. All under a square root. Okay. And then what is this thing? Well, this thing over here is root 9, right? So that's just 3. Here we have 2. And this thing here is 4 plus 21. 4 plus 21, so 5 equals root 25. That sounds good to me. Okay, so let's move on to some of our domain and range questions. Okay, let's talk about any of these guys. I'm not even going to pick some of these guys. I'm just going to make up my own. Okay, so let's say that I wanted to graph and then find the domain and the range of, let's do y equals root x minus 4 plus 2. Okay, well, we know our parent function looks something like this. It starts at 0, right? It goes through 1, 1, and it goes through 4, 2. Right, so it's going to look something like this, right? Something like this. Remember, it's not horizontal. It sort of goes off like this. And then we had this notion of what this minus 4 does and what this plus 2 does. And I encourage us to remember, right, if we're comparing this to y equals root x, let's just think about what this did to the parabola over here. Well, we know that it shifted the vertex to be 4, 2, right? This moved it 4 to the right. This moved it 2 up. The exact same thing happens here. This blue guy shifts 4 to the right, and this green thing goes 2 up. So what does that mean? I'm going to go 4 to the right and 2 up. This is going to be my new sort of starting point, right? And then I'm going to follow the exact same shape from here. So it's just going to look like that. Okay? If we think about the domain of this thing, okay, the domain would be everything to the right and including 4, right? Everything to the right and including 4, right? So that would look like 4 up to infinity. Because if I plug in something less than 4, this thing would be negative, right? We really said, hey, x minus 4 has to be greater than or equal to 0, and then solved, right? And for my range, well, the smallest this thing can be is 0. So when we add the 2, the smallest it can be is 2. And just looking at the graph, we can clearly see that, right? That this thing goes up from 2. Right? So these guys would be my answers. Okay, so let's do another one. Let's do y equals, we'll multiply by 2 this time. We'll do 2 times root x plus 1 minus 6. Okay, so let's pause and think about what that would do. Well, we know, right, my parent guy looks like this, okay? And we know this plus 1 is going to move it left 1 unit, and this minus 6 is going to go down 6. Down 6. We haven't addressed the 2 yet. But we will. Okay, so we're going to go left 1 and down 6. So maybe down here. Okay, and this 2 is going to behave just the way we think it would. Okay, it's going to make the whole thing steeper. Okay, it's going to make the whole thing steeper. It's going to increase faster. It's not a slope. It's going to increase faster. Okay, it's going to increase faster, and it's going to increase sort of twice as fast. So instead of going up to 1, 1, we're going to go up up 2 over 1, right? So we're actually going to have this as our y-intercept, which you could find if you wanted to, right? And it's going to look something like this, right? Sort of gets big faster before it eventually will sort of level off too. But even when it levels off, it grows faster than the other one, right? They never actually really level off. They keep growing forever. So let's talk about the domain of this guy. The domain of this guy, right? We know that we want to set x plus 1 has to be greater than or equal to 0 because x plus 1 is under the radical. So that would mean x is greater than negative 1. And the way we would write that in interval notation is this. Okay, and for the range, we know, right, we started down at negative 6. And so we know we have to go up from there, and we're never going to come back down. So that's sort of simple, right? That's just this guy right here. All right. I hope these guys were helpful. I encourage you to ask me some questions via email. If there's any other type of problem you want me to go through right now, I'll do that. And I will, again, we will address the exponents on Monday. I'm leaning towards heavily de-emphasizing them. Okay, I want us to demonstrate that we can do these 3 skills here. All right. I hope you enjoy your week.